Okay, students, then you write next side heading tangents and angles. Tangents and angles. Okay, then consider this figure. Here, a circle is drawn. O is the center of the circle. O is the center of the circle. And OA. OA is radius and OB is also radius. OA is the radius. OB is the radius. And CA is the tangent, CB is the tangent. Therefore, it is clear that A and B are the point of contacts. Clear? In this figure, two tangents are drawn. That is CA and CB. OA and OB are radii of the circle. Clear? Therefore, you can see a quadrilateral. Which quadrilateral? OACB is a quadrilateral. OACB is a quadrilateral. In this chapter, we studied an important result. What is the result? That is, the tangent is perpendicular to the radius through the point of contact, or the tangent is perpendicular to the diameter through the point of contact. Okay, tangent എന്ന് പറയുന്ന ലൈൻ സെഗ്മെന്റ്, ആ ടാൻജന്റിന് സർക്കിളിന് ടാൻജന്റ് ഉണ്ടെങ്കിൽ എന്തായി മാറും? ടാൻജന്റ് ഈസ് ടച്ചിങ് എ പോയിന്റ്. ഓക്കെ, ദാറ്റ് പോയിന്റ് ഈസ് കോൾഡ് പോയിന്റ് ഓഫ് കോണ്ടാക്ട്. ആ പോയിന്റ് ഓഫ് കോണ്ടാക്ടിലൂടെ നമ്മളൊരു റേഡിയസോ ഡയമീറ്ററോ വരച്ചാൽ ദാറ്റ് ഷുഡ് ബി പെർപെൻഡിക്കുലർ ടു ദി ടാൻജന്റ്. അത് ടാൻജന്റിന് പെർപെൻഡിക്കുലർ ആയിരിക്കും. Here we can say that CA is perpendicular to OA. CA is perpendicular to OA and CB is perpendicular to OB. CB is perpendicular to OB. Therefore, angle A equal to 90 degree, angle B is also 90 degree. Clear? Angle A equal to 90 degree, angle B equal to 90 degree. Then think about the quadrilateral. In quadrilateral OACB, angle A and angle B are its opposite angles. That is, sum of these opposite angles equal to 90 plus 90, 180 degree. Clear? Therefore, we can say that this quadrilateral is a cyclic quadrilateral. Why? Angle A plus angle B equal to 180 degree. Angle A plus angle B equal to 180 degree. Therefore, we can say that it is a cyclic quadrilateral. Cyclic quadrilateral means there exists a circle passing through all the vertices of this quadrilateral. This is which type of quadrilateral? A quadrilateral is formed by two radii and two tangents through the point of contacts. Clear? Then you can write here, in the quadrilateral OACB, the angles at the opposite corners A, B are right angle. So their sum is 180 degree. Thus the quadrilateral is cyclic quadrilateral. Thus the quadrilateral is cyclic quadrilateral. I think you can understand this fact. Okay. Then again we consider this quadrilateral here. The same quadrilateral OACB. Here we proved this quadrilateral is a cyclic quadrilateral. Cyclic quadrilateral. That means there exists a circle passing through all the vertices of this quadrilateral. Here the circle is drawn. Here OACB is the circle. Therefore, angle A plus angle B equal to 180 degree. Then what about angle AOB and angle ACB? Angle AOB and angle ACB. Angle AOB is the angle between radii. Angle ACB is the angle between the tangents. Then their sum is also 180 degree. So, sum of these two angles equal to 180 degree. That implies sum of these two angles also 180 degree. Angle AOB plus angle ACB equal to 180 degree. Below you write angle AOB plus angle ACB equal to 180 degree. That we can write as a result. In a circle, the angles between the radii through the points and the angle between the tangents at these points are supplementary angle. Remember this as a second result. What's the second result? If we draw two tangents to the circle, then draw the point radii through the point of contact. Then there a quadrilateral is formed. There is a quadrilateral formed. That quadrilateral is always a cyclic quadrilateral. Remember, that quadrilateral is also always a cyclic quadrilateral. Then we know the opposite angles of a cyclic quadrilateral are supplementary. Here the angle between the radii and angle between the tangents are always supplementary. Remember this result. Can prove some, we can solve some problem based on this also. Okay, then write this. Then after that, then you consider this figure. Consider this figure. Here a circle is drawn and a equilateral triangle. Here the circle is touching all the sides of this triangle. Circle is touching the sides of the triangle. That means the sides of the triangle are tangent to the circle. Sides of the triangle are tangents to the circle. Clear? That is at this point. Here we can mark the points. At these points, the circle, the sides are contacting to the circle. Contacting to the circle. Then if you draw two radius, then what happened? Here this is 60 equilateral triangle. I told this angle is 60 degree. It's an equilateral triangle. Angle is 60 degree. Then what about this angle? This is two radii. Then now we studied angle between two tangents. At this point, these two line segments are tangents. These two line segments are tangents. Therefore, 60 degree is the angle between the tangents. And this is angle between the radii. They are supplementary. Therefore, this is 60 degree means its corresponding central angle is its supplementary angle 120 degree. Similarly, we can draw other central angles also. Therefore, its central angles are 120 degree, 120 degrees, 120 degree, 120 degree. Why? Because all these angles are 60 degree, 60 degree. Therefore, its corresponding angles are 120 degree, 120 degree. Remember, here an equilateral triangle and a circle. Circle is inside the triangle. Okay, circle is touching all the sides of this triangle. This circle is also known as incircle of the triangle. Incircle of the triangle. You heard the term circumcircle. What is circumcircle? Circumcircle is a circle which is passing through all the vertices of a triangle. But here incircle. Incircle is a circle which is touching all the sides. Touching all the sides of a triangle. Okay, here this is the figure. An equilateral triangle is formed. Then we draw another. Listen, this figure. Here I am drawn an equilateral triangle. Same equilateral triangle. This is an equilateral triangle, and a circle is there. Here the circle is touching the point. This is the first one point. This is the second point, and this is the third point. Here one point. Here the second point, and here the third point. Then if this point is changes. If this point is changes, it become the equilateral triangle is another equilateral triangle is formed. Okay, here the first equilateral triangle is drawn through this point with respect to this point. If this point is moved here, what happened? Another triangle is formed. Just move the point like this. Therefore, like this. Okay. Therefore, 3 here. How many? 4 triangles are formed. 4 equilateral triangles are formed. If you draw such triangles, you will get an interesting geometrical figure. I will draw that geometrical figure like this. This is the figure. Okay, this is a geometrical figure. Here what happened? The equilateral triangles are using the equilateral triangle with respect to circle. If you increase the size, it become very beautiful. And if you can draw 6 triangles or 12 triangles, you will get an interesting figure. You can say it's a geometrical figure using different colors. You can draw it more attractive. Okay.